In this lesson, we're going to implement single sign-on using Keycloak's OpenID Connect authentication protocol with Grafana as our example application to illustrate how the OpenID Connect authentication flow works. So when a user accesses a service like Grafana, Kafka, Elasticsearch, doesn't really matter, but in this lesson, we're going to use Grafana as an example. They're going to be redirected to Keycloak for authentication. Upon a successful login, Keycloak issues both an access token, which grants permission to use Grafana or whatever service you're giving single sign-on, and an ID token, which contains the user's identity and role information. Grafana or whatever software uses the access token to decide if it should grant the user access to simply use the application. It also uses the payload from the identity token to be able to verify the identity of the user, who they are, and what kind of permissions they're allowed on the service. In Grafana, that's whether that person is an admin, editor, or viewer. This is what makes OpenID Connect very powerful. It extends on the traditional OAuth protocol by also providing identity information, not just simple user access. It enables services to not just authorize users, but know exactly who they are, so that the service knows what kind of roles and permissions they're allowed to have. This tutorial is completely hands-on. I'm going to provide you with all of the necessary configuration files, so let's just dive right into it. But before doing so, I just want to deliver a very quick message. If you find these DevOps tutorials helpful, consider subscribing to this channel for more DevOps and cloud native content. Also, if you're looking for a complete Kubernetes course that teaches the best practices for cloud native app development and deployment, check out my course by clicking the link inside the video description. Kubernetes is the cornerstone of modern cloud infrastructure, and my course covers it all. All right, back to our demo. All right, the first thing you need to do is download all the project files that are needed to follow along with this tutorial. I left you a link to the GitHub repository inside of your video description. Make sure that you click on it and go to this GitHub repo. Once you're here, clone it inside a directory of your choice. It doesn't really matter which one it is, as long as you have easy access to it. I've got it inside of a directory called YouTube tutorial, which I can drag to my favorite text editor, Visual Studio Code, and work from there. All right, so I've already got the installation setup already done for you. All you need to do is copy the commands that I provided inside of the README for the same GitHub repo I just linked you to. Two things before we begin the installations. Just to make sure that you're consistent with my setup and your learning experience isn't disrupted, make sure that you're using a Kubernetes cluster that is set up locally via Docker desktop or Minikube branch or desktop, doesn't really matter. If you need to set that up before starting this tutorial, feel free, the link is right here. And make sure that you've got Helm installed as well, because that's what we're going to be using to install Keycloak as well as the monitoring stack, Grafana specifically. All right. So once you've got that set up, the first thing we need to do is add the Helm repository that contains the Keycloak Helm chart to our local Helm config. I've already got that set up. And the next thing you want to do is install Keycloak via the Keycloak Helm chart in the Bitnami Helm repo using the values file that I've already configured for you, which configures our installation. And this portion over here is mainly why I've encouraged you to follow along with a K8 cluster set up locally on your machine, because we're configuring Keycloak to be accessed on our computer's port, on our node's port 30,080 for local testing. Obviously, once you're finished learning, and if you want to scale this to a production-ready cluster afterwards, you can just change this to load balancer, and it's going to configure your load balancer at the edge of your Kubernetes cluster to receive all that traffic. Okay, but again, highly recommend you stay consistent with me. All right, and the next thing we want to do is set up Grafana. So we're going to install the whole monitoring stack. Helm repo add Prometheus. We're going to add the Prometheus Helm repo, clear the output, and from the Prometheus community Helm repo, we can install the Kube Prometheus stack. specifically modifying the Grafana component of that stack using the following values.yaml file, which I've already configured for you, but which we're going to make a lot of changes to in accordance to all of the Keycloak fundamentals that we learn. All right, so don't worry about it for now. Everything here is going to be explained. And everything we learn here doesn't just apply to Grafana. Once you learn the authentication flow, this can be applied to any application you want to give single sign-on capabilities. That could be Kafka, that could be Elasticsearch, that could be whatever you want, okay? So let's go ahead and finalize this installation. May take a little bit of time. Also, in case I haven't mentioned this already, the reason we're installing Keycloak and Grafana is because we're going to be configuring Keycloak so that it can provide our Grafana application with single sign-on capabilities. All right, so now that that's been deployed, the final thing we need to do to complete our setup and actually begin our tutorial is to make sure that you've got Postman downloaded. If you don't, please make sure that you download it through this link in your GitHub repo because we're going to be using it for testing and troubleshooting. All right, so I'm going to go ahead and open up Postman for me right now. And into it, I am going to import the following Postman collections file. So let me reveal that. Reveal in File Explorer if you're using Windows. Drag it over here, because we're going to be using this Postman collection to troubleshoot retrieving the access token, getting the user info from Keycloak, and making sure that our authentication flow is actually flowing. All right, so that's it for the setup. Let's go ahead and commence this tutorial. I provided you with a diagram that illustrates how the authentication flow is going to work. So regardless of which app you're granting single sign-on capabilities, whether that's Grafana, Kafka, or Elasticsearch, whichever app relies on Keycloak for single sign-on, that would be deemed a Keycloak client. You yourself, the user who's trying to sign in to one of these applications, in this case Grafana, you would be deemed a user. So what we need to do in Keycloak is set up an authentication space that stores all of the users that need to sign in, what roles they would have inside of whatever application they're trying to sign into. Okay? Every client that you store in your Keycloak realm is going to have a client secret. Every user that you store in the Keycloak realm is going to have a username and password. Why? Because once we're done setting up all of the authentication components, now let's imagine that I'm inside of the Grafana homepage and I click the sign in with Keycloak button. What's going to happen is the client, in this case Grafana, is going to provide a client secret. Okay, that client secret needs to match what's inside of the Keycloak realm. If it is, then the authentication request is going to be deemed valid. Keycloak has verified that this is an official Keycloak client. All right, and the user who's trying to sign into that client, to that application, using Keycloak needs to provide valid Keycloak user credentials. If these are valid, then Keycloak will effectively allow that user to sign into the client, Grafana in this case. How does it do that? So upon a successful authentication request, tokens are issued. Two types of tokens. There is an access token and an ID token. An access token authorizes the user to gain access to the client's services. In this case, it would authorize me to access Grafana. The ID token that Keycloak gives the client tells the client who I am. And from there, the client can decide what roles to give me within its services. So in this case, whatever identity Grafana gets back from Keycloak, it can decide if I'm a Grafana admin, if I'm a Grafana viewer, or if I'm a Grafana editor. So this is where OpenID Connect goes a step further than typical OAuth, because a simple OAuth flow would simply grant the user with an access token to access the client's secret. But OpenID Connect goes even further in also telling the client our identity, giving it the ability to identify us, whereby the client can then decide what role we can have within whatever services it provides. And ultimately, all this is saying is when we have the right tokens issued, we're able to access whatever protected resource is being protected by the client. Okay, and that's pretty much it. So this is what we need, but this is what we have. All right, so now what we need to do is say kubectl get pods dash and Keycloak in order to make sure that all of our components are running. Keycloak is, so as the PostgreSQL database that's storing all of its data, let's say kubectl get pods dash and monitoring. Everything is running except the node exporter. We don't really care. Anyways, all we care about is Grafana. I'm going to say kubectl get service dash and monitoring to see which service can provide us access to Grafana. It is the following. So now what we can do is say kubectl port forward. We want to port forward the following services port 80 on our port 3000. Okay, really important that you actually choose port 3000. All right, and we say dash and monitoring. And now let's go ahead and access Grafana. So host 3000. And I can choose this sign in with Keycloak option because I've configured your Grafana installation to have this option, but it's obviously not going to work. We get a "we're sorry, page not found." Here is why. So the reason is it's trying to access a Keycloak realm called test realm, but that realm doesn't even exist. We haven't set up any of these authentication components. We haven't set up a client inside of Keycloak, so Grafana can't identify itself using this client ID. So none of these should work until we actually start setting some stuff up in Keycloak. All right. For our Kubernetes environment, what we need to do is say kubectl get service dash n Keycloak. We have a node port service that's running Keycloak on our nodes as port 30,080. So here I'm going to say localhost 30,080. So for my Kubernetes users, the credentials that you're going to use to log into your admin portal is admin and admin. Simple enough. So now the first thing that we need to do is set up a realm. I'm just going to create a new realm, call it Grafana. Create this realm. And we can already start making changes. So now that we've got our realm, Grafana, let's go ahead and make adjustment to our configuration file. So wherever it says test realm, change that to Grafana. All right. These URLs are unique, as I'll show you in Postman just a bit, because in this case, Grafana is going to be using them to access tokens, get user information, so on and so forth. All right, so test realm, change that to Grafana, Grafana. So now these should be fine. And so here you'll notice the authentication URL must be accessible from the user's browser, whereas the token URL and API URL are requests that are directly made between Grafana and Keycloak internally. But this begs the question, why does this one need to be accessible from the browser? Well, you'll remember that when we click that sign in with Keycloak button from the browser, we need to be redirected on the browser to the following endpoint where the authentication token can be retrieved, the access token, thereby allowing the user access into our Grafana service. Okay, so this needs to be accessible from the browser accordingly. So the realm we've got figured out. The next thing we got to change is the following. So now let's go ahead and create a new client. The client in this case, I'm also going to call Grafana because because Grafana in this case is a client of Keycloak requesting single sign-on capabilities. All right, we're going to click next. Standard flow, yep, works for me. The root URL is where your client is running, in this case, localhost 3000. Now I believe we may have stopped our client. Let me say kubectl get service, whoops, dash n Grafana yet again. Oh, not Grafana, dash n monitoring. Now we can say kubectl port forward the following service dash n monitoring. We want to map this to localhost 3000, and we'll put an ampersand at the end just so that it keeps running in the background even if we stop the command. All right, so that should work fine now. Anyways, I got sidetracked. Valid redirect URIs is interesting, and that's where Keycloak is basically allowed. That's where we can allow Keycloak to send users after logging in. I don't remember specifically where Grafana expects users to be sent after a successful authentication. So what I'm going to do is just copy the URL, put an asterisk to say allow users to be sent on all Grafana paths, wherever Grafana decides to send them after Keycloak does the authentication. Okay, do the same thing for logging out. Web origins is usually the same thing as the root URL because that's just for to accommodate for cross-origin requests. Okay, so we've got all that set up. We can go ahead and save it. All right, next thing we want to do is turn on client authentication. I thought I already had that turned on, but whatever. Save. As we turn on client authentication, we should see an access token right over here. Sorry, a client secret, not an access token. That's the secret that Grafana is going to use in order to prove that it's a valid Keycloak client, as long as it can provide the secret that Keycloak is expecting. And its client ID is going to be Grafana. All right, we're almost done setting things up. So now, when we press that sign in button and our client Grafana gives the client secret, deeming this authentication request to be valid, we're going to be redirected to Keycloak's main page where it's going to expect user credentials. These user credentials, if Keycloak deems them to be valid, will be used to authenticate against our client, and thereby access tokens will be issued where they can actually access the application itself. So what we need to do is go to users. We're going to add a new user. I'm going to call the user Rayanne. You can call it whatever. Our slim ray@gmail.com. First name Rayanne, last name Slim. I'm just going to make sure I remember these. Create. Then go to credentials, set password. I'm just going to give Rayanne a password of password. Like so. Save password. Okay, so now do we have enough? Let's find out. Let's first start by making a request in Postman. So go to your first post request where you can get an access token. So the access token basically authorizes our user to access the client. So the client is Grafana. All right, the client secret, we're just going to copy over. So remember, even though we're not actually using Grafana in this case to make this request, we still need to provide a correct client ID and secret so that the authentication request can be deemed valid by Keycloak. All right, the username was Rayanne. The password I set as password. And let's go ahead and make this request. Realm does not exist. Sorry, this should be Grafana. Account is not fully set up. Interesting. I'm glad we did this Postman request before doing anything else. Let me reset the password. This should not be temporary. Anyways, let's reset the password to password. All right, save it. Okay, we'll try this again. All right, so we were just given an access token that would effectively authorize the user, Rayanne, to access the Grafana client. All right, so what would happen if we made that same request from over here? All right, so let's go ahead and do that. So localhost 3000. I'm going to go ahead, why is this so small, and sign in with Keycloak. Page not found. Oh, what we're going to have to do is rerun things because it's still making requests to test client. So let's stop that. For my Kubernetes fellows, I'm not gonna Helm upgrade. I'm gonna Helm uninstall the Prometheus release we have right now that it's inside of the monitoring namespace. And I'm gonna get the command from our GitHub repo from earlier to reinstall it. All right. Alrighty, let's rerun that port forward command. Oh, interesting. kubectl get pods -n monitoring, make sure everything is running. Okay, Grafana's fine. Let's try this again. Okay, we're good. We're going to sign in with Keycloak. Beautiful. Client ID Grafana, you can see it right here. We were sent to some realm. I don't really see it, but hey, it's somewhere here. So now that the client has provided a valid client secret, now it's our turn to provide valid user credentials. So we'll go ahead and do that right now. Let me close these. Username I think was Rayanne. Password I set to password. Sign in. And it redirects back to localhost 3000 at whatever path. And here we can see that we were effectively signed in using Keycloak. Signed in using my preferred username. So that's where all of this stuff comes in. Name attribute path, email attribute path. Those are all information that is provided. And you might be wondering, how does Grafana have access to all of this information? How did it retrieve this info from Keycloak? Well, you'll remember that it's connecting to this user info endpoint. And the access token that it's given also encodes a lot of information. The ID token it's given as well. We haven't really talked much about that. So we can go ahead and decode. Here, let me resend this. We can go ahead and decode this access token in order to see what kind of information Grafana is getting. So if we go to jwt.io, so this access token contains an expiry date. So if you decode this to something more user-friendly, 5 minutes from now, this bearer token won't be valid anymore. And here we can see things like name, given name, family name, etc. But the ID token is actually where it's able to verify the user's identity and what role they should have. So if we look at the ID token itself, again, this is what helps Grafana effectively verify who you are. The ID token is what it checks. And we're not really giving Grafana any interesting information here. So we're giving it the name, the family name, etc., but we're not telling Grafana what role this user should have within its service. So Grafana by default is just going to give them the viewer role. Okay. So that's something that we need to encode within the ID token, what role each person should have. Because as you can see here, so this configuration is specific to Grafana. Kafka or Elasticsearch would have similar implementations. But essentially here, Grafana gets information from the ID token and it checks if there is a realm access role that equals the string admin, then it's going to give that user who logged in the built-in Grafana admin role. Otherwise, it's going to give it the viewer role that you just saw. So again, this user info endpoint is interesting. So if I go to user info and I paste in, let me get a new token. I think this one expired because I was talking too much. Let me get a new token, put it in the user info, put it here so that we can access this endpoint. Realm does not exist. This should be Grafana. So again, the user info also reflects what kind of information our client is going to get back about our user. Again, none of it really describes the role that they would have. So let's go ahead and encode that because I want myself, Rayan, to be given admin rights in Grafana. So now, inside of Keycloak, oh, did we lose it? I guess we did. All right, cool. Just make sure that you go back to the Grafana realm, not the master one. And so now we need to define how Keycloak adds specific user information like roles into tokens or user info responses so that when the client sees those tokens, knows how to properly identify the user and what roles to give them. So we'll define the client's scope, the scope of information that they're going to see. Realm roles user info is what I'm going to call the client scope. We'll set this to default. Press save. Then go to mappers. Add a predefined mapper. And I'm going to say user realm role, see what I get. We're going to add this mapper. And what this basically does is it ensures that whichever user is trying to sign into this client, it will include that user's realm level roles in the token or the user info so that the client has the info that it needs to give them its own proper built-in roles, okay? Without this, Keycloak won't include these roles by default. But now we need to bind this client scope to the client itself so that the client knows to want this information and so that Keycloak includes it in the token accordingly. So now we go to the Grafana client. We go to the client scopes and we want to give it the client scope we just created, realm roles user info. Make sure that's the default. All right, is it there? Let me just make sure. Indeed it is. And actually one thing I forgot to do before we test anything out, go to realm roles user info. Go to mappers, go here. I want to also add the information to the user info endpoint. All right, and now, oh, add to ID token as well. This is the most important step because the ID token is what Grafana is going to use to identify the user and whatever. So now let's press save. And get an access token. Now, this same access token, which authorizes the user to access whatever client, in this case Grafana, can also be used to access the protected user info endpoint from Keycloak. So let's put that in there, press send, and now that user's role is included, the fact that they're an admin. Beautiful. And it's also included in the ID token that was given back, which is what Grafana is going to rely on in order to know who that person is. Perhaps it also uses the user info endpoint, who knows? Anyways, if you decode the ID token, we see the admin role. So now Grafana can effectively look at realm access.roles, check for admin. If it's there, it's going to map it to the built-in admin role that Grafana itself knows about, okay? And that's it, guys. We're done. Only one way to test this out is to do everything through Grafana itself, not through Postman, right? So now we know Grafana is going to get that information because it's going to be included in the ID token it gets back. So if I sign out, sign back in with Keycloak, is it actually going to read the admin role and know to assign them its built-in admin role? Indeed, it will. That's it, guys. I really hope you enjoyed this demo. Now it's time to clean up. So cleaning up is going to be fairly simple. Helm uninstall Keycloak in the namespace Keycloak. Helm uninstall monitoring, or no, Prometheus in the namespace monitoring. That's going to take a while. Let's just give it a second. All right, uninstalled. I'm using Docker Desktop, so I'm going to delete any loose stuff that was in it. Docker system prune -a. That should free up some storage space, 1 GB of storage. And I'm going to go over to my Docker dashboard, go to volumes, make sure there's nothing else in there. I think we're good. All right, guys, that's pretty much it. If you want to tune into more DevOps content, make sure to subscribe. And if you find these guides helpful, make sure to check out my Kubernetes training course for the latest cloud native content. Can't wait to see you inside.